Here we're going to start looking at practical plane geometry, and in section 1 of chapter 3 we'll look at angle measurements. Geometry is one of the oldest branches of mathematics, and it involves the study of properties of points, lines, planes, surfaces, and solid figures. So we're going to start by looking at angles. An angle is a measure of the size of an opening between two intersecting lines. The point of the intersection is called the vertex, and the lines forming the opening are called the sides. So here in this figure you can see we have our sides here, and then our vertex would be there. An angle may be identified in any of the following ways. You may call it angle D with only the vertex letter. You may call it angle E if it is the letter or number placed inside the angle. You may also call it angle ABC, and notice that the vertex letter is in the middle. So here we're going to give 3 different ways we can express the following angle. So we could call this angle M by using that inside value. We could call it angle K by using just that vertex value, or we could call this angle JKL or angle LKJ. Either way would be the same. So angles are measured according to their size of their opening. The length of the sides of the angle is not related to the size of the angle. So even though you can see in this picture that the first angle it may look longer or larger than the second one, because the angle measures are the same, the angles are the same size. An angle is the amount of rotation. So you can see here that if we have this side and we move up, that is a rotation, and that's what's giving us this angle measure. The basic unit of measure of angle size is a degree, and that is because we think about it as a full circle, and a full circle is 360 degrees. So we are going to be looking at the measures of angles in terms of degrees. So how do we measure an angle? We'll be using a protractor, and you can see a picture of one here. I'm going to do some examples on the next slide and give you the opportunity to try, but here we have a lot of different angles marked, and you will need to be able to read these angle measurements. Now, notice that we have some things here clockwise and then counterclockwise. So depending on the opening of the angle is which part you will be reading, the top numbers or the bottom numbers. So here I want to look at what is the angle measure of DOE. So we have angle DOE. Notice that this angle opens counterclockwise, so we are going to be reading the inside values. Okay, we're looking for where is that marked at 0, so here's our 0, and then we're going to read up, and so angle DOE is 60 degrees. Here I'm looking at what is the measurement of angle AOD. So here's my AOD. Notice that this one is opening clockwise. Here's my 0. So I'm going to read up and over to my other side that is OD. And that value is 120 degrees. I would like for you guys to try the next 4 problems. You can pause the video here, and then when you start it again, you will see the answers. Now we're going to look at drawing angles using a protractor. So I'm going to do the first two, and then I'll leave a protractor open that you can practice doing number 3 and 4. So let's look at number 1, a 30-degree angle opening counterclockwise. So we know that it's going to have I'm going to do number 1 in yellow. Our 0 and up to 30. Okay, this is just a sketch here, so it's not perfect. And then a 30-degree angle opening clockwise. And this time, notice we're going to be using those upper numbers, the ones on the top. So there's that. So now you can take a minute and try the 110 degrees and the 160 degrees, and then so pause the video, and then when you come back you'll be able to see the answers. Now we also can classify angles. So an acute angle is an angle less than 90 degrees. You can try to remember this as a cute little angle. An obtuse angle is greater than 90 degrees but less than 180. So those are going to be your larger opening angles, and you can see some different figures here. And then we have a right angle that is exactly equal to 90 degrees. They should be like a corner, and it may be marked with a little square in the corner or an actual 90 degrees written there. So two straight lines that meet at a right or a 90-degree angle are said to be perpendicular. So here in this illustration, we can see that CX is perpendicular to XE because they meet at a 90-degree angle. We also have straight angles. A straight angle is an angle equal to 180 degrees. So here you can see the angle BOA is a straight angle because it is equal to 180 degrees. For any pair of intersecting lines, the opposite angles are called vertical angles. Vertical angles are always equal. So this means that angle A is equal to angle C, and angle B is equal to angle D. For any pair of intersecting lines, the opposite angles are called vertical angles. When two lines intersect, the sum of each. For any pair of intersecting lines, this should state that any adjacent angles, so angles that are side by side, are equal to 180 degrees. So that means that when two lines intersect, the sum of the pair of adjacent angles is 180. So here, if you take a look at angle B plus angle C, you should get 180 degrees. Angle A plus angle B should be 180 degrees. Angle C plus angle D should equal 180 degrees. So notice that any way that I do this, I should get 180 with two angles that are side by side. So looking at triangles, a triangle is formed from three distinct line segments. The line segments are called the sides of the triangle, and the points where they meet are called vertices. So here we have interior angles. Interior angles are angle A, angle B, angle C. If you take all of those interior angles and put it together, you should get 180 degrees. So the inside of a triangle always adds to 180 degrees. When two parallel lines are crossed by a third line, called a transversal, several angle relationships occur. So here, I'm just going to make sure you see everything. We have our parallel lines cut by line XY. So that's XY is our transversal. So what happens to these angles? We have alternate interior angles are equal. So here you can see angle C and angle F are equal, angle D and angle E are equal. Also, corresponding angles are equal. So we have that angle from AB, so A plus B is equal to E plus F. That also means that angle A is equal to angle E. And on the other side, you could see angle C is equal to angle G. So with that information, if you were given a problem where you had two parallel lines cut by a transversal and were only given one angle, you should be able to figure out all the other angles. So I'm going to call this P, Q, R, S, T, U, and let's do W. Okay, so remember that alternate interior angles are equal, corresponding angles are equal. So if you start, let's say, with angle S, because angle S corresponds with the 70 degrees, then angle S has to be 70 degrees. Okay, we also know about straight angles. So that means this first angle here plus P has to be 180. So if you do 180 minus 70, you should get 110 degrees. Well, vertical angles are congruent. So that means that since angle P is 110 degrees, Q has to also be 110 degrees. Again, we have a straight angle, so there we've got 70 degrees for angle R. Angle T has to be 110 degrees. Angle U has to then be 110 degrees. And because angle S is 70 degrees, then angle W has to be 70 degrees. Here is your practice for 3.1 out of your workbook. Again, you can use your e-text that is located in your My Math Lab. And then you also have your My Math Lab 3.1 homework for practice.